In this video, we will see some of the functions of NumPy that are used to create NumPy arrays with some default values populated in them. In particular, we will look at linspace, zeros, and ones function. So what this linspace does, it takes one start and stop parameter, and these are mandatory, and some other parameters, which we will see example of that. You can also look at a detailed explanation of the different parameters on its official documentation website. And it creates an NumPy array from this start to stop. And you need to give some step size. Here the num is some default value, but you can give, let's say, step size of 10. Then it will start from this starting value, and it will divide that start and stop into linearly sized values. That's why linspace, or equal distance values. The next function would be zeros. So as the name says, zeros, so it will create a NumPy array whose all the values will be 0, and you need to pass a shape parameter. Let's say I want an array of 3 cross 5, that is 3 rows and 5 columns. Then you will pass that shape. You can have even more dimensions, and it will give you a NumPy array of same dimension, whatever you have mentioned, all initialized with 0. And you can see a default D type, so it's not mandatory. So if you don't give, it will create all zeros of float types, that is 0 dot dot. If you pass explicit D type, it will take it as int. And very similar is the ones function. Here also you pass the shape, and similarly it will create a NumPy array of the given shape, but all initialized with ones. So let's see example of all of these three. So let's say first we need to import NumPy as np, then arr1 equal to np.linspace, and let's say I want from 5 till 20, and let's complete it in 15 steps. So it will start from 5, it will go till 20, and this will be inclusive, unlike the arange function. And it will take 15 steps. It will take, in fact, 14 steps. So it will create 15 elements equal sized. The step size will be equal. So let's see what it creates. Let's also print this arr1. So you see equal spaced values. So actually these are 15 values, but the difference is here 16. So let's put 16 here. So the step size would become 1 now. Yes, so it creates 5, 6, 7 all the way up to 20. So it divides, it starts from here, ends here, both inclusive. And how many values? 16, and all will be equally spaced. So that's the purpose of linspace. And it's very useful in some scenarios. And you can also pass a return step parameter here, which was optional. So it will also return you what was the step size that it took. So let's create another array, and this time we will create it the same size, 5, 20, and 16. And we pass ret step equal to true. So by default, it will not return the step size, just return the NumPy array. But if you pass this, it will return 2 values. So this is the array, and the second thing is this is step size 1. Here they are equally spaced. So if you make it 15, then you see the step size is 1.0714, and if you multiply it with 15, you will get 16. So total the distance is 16, but total elements are 15. So that's how linspace is used. Next, we will see zeros. So let's create one text here. So you see it creates a NumPy array of 5 elements, each initialized with a value of 0. Then let's create some other dimension. We have been dealing with linear arrays for now, one dimensional, np.zeros, and we pass 3, 5. And you can see a 3 cross 5 two-dimensional NumPy array, and you will see that here there are 2 opening braces and 2 ending braces. Here it was just one bracket, and here the first axis or first dimension is 3. So there are 3 arrays, each of 5 elements. So it opens here, ends here, and the first element is 5 elements, again 5 elements, and again 5 elements. That's why 3 cross 5. Let's create one 3D array. So np.zeros 2, 3, 5. And you can see that it has created two-dimensional matrices, each of 3 cross 5, and the first dimension is 2, so there are 2 of them, 2 of 3 cross 5 matrices. So this you can use to create different shaped NumPy arrays, each initialized with 0. And this can be used in your training of neural network, where you want to initialize some weights with 0, or it can have multiple uses, this zeros, ones, and linspace, all of these. Now let's add an additional parameter here. So you will see that each of these are floating point. These are initialized with 0, but these are floating point. And all the elements should have the same type. So what if I want all these to be initialized with 0, but integer, not floating type? Then we will write it as np.zeros, the same thing, 2, 3, 5, and we pass additional parameter dtype, int 64. Now you see these are all int types, not float. By default, these are float. Now let's do the same thing for ones. If you have understood zeros, there will not be much difference in ones. These are very similar. So np.ones 5, np.ones 3, 5. Again, here shape should be passed, and then np.ones 3, 5, and here also you can pass that dtype. And here you notice that these are all floating point types, 1 dot, 1 dot, all of these elements are floating point by default. You can make them integer and it becomes all integral ones. Similarly, you can have more dimensions. So these were the 3 methods, and these come in very handy at different places.